We are Team 5 from Grand Valley State University. Our senior design project was completed in partnership with Corvac Composites. The objective of our project was to design and build an automated robotic ultrasonic welding system capable of welding NVH pads onto automotive fender liners. Throughout this presentation, we'll discuss the problem, our solution, the technologies we implemented, the challenges we overcame, and finish with a live demonstration of the completed system. Corvac currently welds prototype and service parts manually using a handheld ultrasonic welder. Because this process depends heavily on the operator, weld quality can vary from part to part, resulting in inconsistent welds, burn-through, or incomplete welds. Our objective was to automate this process to improve weld consistency, repeatability, and efficiency. To accomplish this, we integrated an ABB IRB 6620 robot with a Keyance ultrasonic welder, pneumatic actuation, an Alan Bradley PLC, an industrial HMI, and a complete safety system including a Keyance area scanner and dedicated safety controller. Our design was required to meet several performance specifications established by Corvac. The system needed to complete each weld in under 4 seconds while maintaining a weld failure rate below 20%. Each weld also had to be placed within plus or minus 10 millimeters of the target location and achieve a minimum tensile strength of 20 newtons. In addition, the system needed to accommodate HDP fender liners up to 6 feet long while operating safely within a 4x3 meter work area. The completed welding cell consists of several integrated subsystems working together. The ABB robot positions the ultrasonic welder at each programmed weld location. The custom end-of-arm tooling applies the weld force, while the fixture securely locates the part. The HMI provides operator control, and the Keyance area scanner ensures the robot only operates when the work area is clear. All of these components are coordinated through the PLC to create a fully automated welding process. One of our primary mechanical design tasks was developing the custom end-of-arm tooling. The Keyance ultrasonic welder is mounted to a linear rail system and actuated by a dual-acting pneumatic cylinder. This design ensures the weld horn moves in a straight line while maintaining proper alignment with the part surface. The mounting structure minimizes deflection during welding, allowing consistent weld force and repeatable weld positioning throughout the welding cycle. The base fixturing system was designed to provide repeatable positioning for every part. The fixture is mounted to a table designed around Corvac's existing base plate and is secured using locating features and clamps. This allows the operator to quickly load and unload parts while ensuring every weld begins from the same known location, improving both accuracy and repeatability. This project required the integration of several industrial automation technologies. The system is controlled using an Alan Bradley Compact Logix PLC and an ABB robot programmed in Rapid. A Factory Talk View HMI provides operator interaction, while Ethernet/IP and IO-Link communication connect the robot, welder, sensors, and safety devices into one integrated system. One of the largest challenges was integrating several independent industrial systems into one reliable automated process. Establishing communication between robot, PLC, HMI, ultrasonic welder, and IO-Link devices required extensive testing and troubleshooting. Another challenge involved configuring the IO-Link network to reliably communicate with sensors and field devices while providing real-time feedback to the PLC. Midway through the project, the sponsor also changed the production part assigned to our team. This required us to redesign the robot weld paths, update our validation testing, and continue meeting project deadlines despite the change in scope. Finally, we developed the automated process sequencing for the entire welding cycle. This required designing a PLC state machine capable of coordinating robot motion, pneumatic actuation, ultrasonic welding, operator interaction, and safety interlocks into one automated process. As shown here, the operator begins by loading the fender liner into the fixture and positioning the NVH pad. Once the NVH pad is placed, a weld template is placed onto the assembly to hold the NVH pad into place. The weld template is then clamped to the liner. Once the part is secured, the operator exits the work area and resets the area scanner. After enabling the robot motors, the welding cycle is started from the HMI. The robot first moves to the initial weld location before the pneumatic cylinder extends the ultrasonic weld horn toward the part. The ultrasonic welder applies the programmed welding parameters. Then the horn retracts, and the robot advances to the next weld location. This sequence repeats until all 8 weld locations have been completed for the part number. Once the final weld is finished, the robot returns to its home position, signaling that the welding cycle is complete. The operator can then safely unload the finished part and prepare the system for the next production cycle.